ನನ್ನ ಹೆಸರು ಗೋಪಾಲ್ ಕೃಷ್ಣ ಗೋರೆ. ಸರ್ಕಾರಿ ಪದವಿ ಪೂರ್ವ ಕಾಲೇಜು ಬೈಲೂರು ಇಲ್ಲಿ ಸುಮಾರು 22 ವರ್ಷಗಳಿಂದ ಭೌತಶಾಸ್ತ್ರ ಉಪನ್ಯಾಸಕನಾಗಿ ಸೇವೆ ಸಲ್ಲಿಸ್ತಾ ಇದ್ದೇನೆ. ಟುಡೇ ವಿ ಹ್ಯಾವ್ ಟು ಲರ್ನ್ ಅಬೌಟ್ ದಿ ಇಂಪಾರ್ಟೆನ್ಸ್ ಆಫ್ ಫೋರ್ಸ್ ಇನ್ ಮೆಕ್ಯಾನಿಕ್ಸ್. You had already studied few familiar words like position, speed, velocity, acceleration, etc. Now, in this chapter, you have to learn that what moves and what causes to move. It means that when objects gain velocity or when it achieves acceleration, etc. Initially, 1000 years ago, a philosopher known as Aristotle, he told that a continuous force is required to maintain a continuous motion of a body. It means that if you apply an external force continuously, then only the object moves continuously. Otherwise, it comes to rest immediately. For example, let us consider a small car toy. If you push it by applying a force, it will cover a certain distance, immediately it comes to rest. Later, once again, if you apply a force on that body, it will move further. Therefore, a continuous force should act on a body to maintain continuous motion. This is according to Aristotle. But as the physics develops, new discoveries takes place. And according to new discoveries, especially Galileo, ಆಧುನಿಕ ವಿಜ್ಞಾನದ ಪಿತಾಮಹ ಅಂತಲೇ ಗುರುತಿಸಲ್ಪಟ್ಟಂತಹ ಒಬ್ಬ ಶ್ರೇಷ್ಠ ವಿಜ್ಞಾನಿ, ಅವನು ಇದೇ ಕಾನ್ಸೆಪ್ಟನ್ನು ಬೇರೆ ರೀತಿಯಲ್ಲಿ ಯೋಚನೆ ಮಾಡ್ತಾನೆ. ವೈ ಆಬ್ಜೆಕ್ಟ್ ಕಮ್ಸ್ ಟು ರೆಸ್ಟ್ ವೆನ್ ದಿ ಫೋರ್ಸ್ ಈಸ್ ವಿಡ್ರಾನ್. ಒಂದು ವಸ್ತುವಿನ ಮೇಲೆ ಬಲಪ್ರಯೋಗ ಮಾಡಿದಾಗ ಅದು ಸ್ವಲ್ಪ ದೂರ ಚಲಿಸ್ತಾ ಹೋಗಿ ಮತ್ತೆ ಕೂಡಲೇ ಅದು ಯಾಕೆ ರೆಸ್ಟಿಗೆ ಬರ್ತದೆ? Finally, he thought that it is because of friction. It is the frictional force acting between the surface and the object. So therefore, now let us imagine a smooth surface. If you apply a same force on that body, definitely that object covers a larger distance and finally comes to rest. Therefore, for the same magnitude of force, the object travels different distances. So, for the motion of the body, not only force is important, but also the nature of the surface. If, let us consider a surface which doesn't have any friction at all, that object definitely is keep on moving. Therefore, the Aristotle's statement is found to be wrong, and therefore that statement is now called as Aristotle's fallacy. ಅದೊಂದು ತಪ್ಪು ಭ್ರಮೆಯಾಗಿ ಅದು ಪರಿಣಮಿಸಿತು. ಹಾಗಾದರೆ ಸರಿಯಾದಂತಹ ವಿಶ್ಲೇಷಣೆ ಯಾವುದು? ಗೆಲಿಲಿಯೋ ಅದನ್ನು ವಿಮರ್ಶೆ ಮಾಡಿದ. ಒಂದು, ಆಬ್ಜೆಕ್ಟ್ ರೆಸ್ಟ್. ಎರಡನೇದು, ಆಬ್ಜೆಕ್ಟ್ ನಿರಂತರವಾಗಿ ಚಲಿಸ್ತಾ ಇರುವಂತಹದ್ದು ವಿತ್ ಯೂನಿಫಾರ್ಮ್ ವೆಲಾಸಿಟಿ ಎಸ್ಪೆಷಲಿ. ಸೊ ವಿ ನೋ ದ್ಯಾಟ್ ವಾಟ್ ಇಸ್ ಮೀನ್ ಬೈ ಎ ರೆಸ್ಟ್. If the object occupies the same position with respect to different time intervals, then the object is said to be at rest. When the object is said to be in motion, if it occupies the different positions in different intervals of time. If the force is acting on your body, definitely, if the object is initially at rest, starts moving, or if the object is moving, it comes to rest. It comes to rest. So therefore, this is the action of a force. ಹಾಗಾದರೆ ಈಗ ಫೋರ್ಸ್ ಅಂದರೆ ಏನು? ಅದು ಎಲ್ಲರನ್ನ ಕಾಡುವಂತಹ ದೊಡ್ಡ ಪ್ರಶ್ನೆ. ಫೋರ್ಸ್, ವಿದ್ಯಾರ್ಥಿಗಳಲ್ಲಿ ಫೋರ್ಸ್ ಅಂದರೆ ಏನು ಅಂತ ಹೇಳಿದ ಕೂಡಲೇ ಬಲ ಅಂತ ಹೇಳ್ತಾರೆ. ಆದರೆ ನಿಜವಾದ ಡೆಫಿನೇಷನ್ ಏನು? Now we have to study the definition of force. Force is an external agency like pull or push which acts on a body to change the state of the body. Or it is the external agent which, like pull or push, which acts on a body to produce acceleration in a body. That is the force. And this force is responsible for the motion of objects. If you apply a force on a body, the object starts moving with the higher velocity, or it gains acceleration, or if the object is moving, it may come to rest by the application of force, like that. So therefore, if you apply a force on a body, there are so many changes takes place. Now, according to Galileo, the state of rest and state of uniform motion along a straight line, both are equivalent. On that basis, Newton gave three important formulae. In 1642, ವಿಜ್ಞಾನದ ಪಿತಾಮಹ ಅಂತ ಗುರುತಿಸಲ್ಪಟ್ಟಂತಹ ಗ್ಯಾಲಿಲಿಯೋ ಈ ಪ್ರಪಂಚದಿಂದ ಕಣ್ಮುಚ್ಚಿದರು. ಆದರೆ ಅದೇ ವರ್ಷ ಮತ್ತೊಬ್ಬ ಪ್ರತಿಭಾವಂತ ವಿಜ್ಞಾನಿ ನ್ಯೂಟನ್ ಜನ್ಮ ತಾಳಿದರು. ಆದ್ದರಿಂದ 1642 ಎನ್ನುವಂತಹದ್ದು ಒಂದು ವಿಶಿಷ್ಟ ವರ್ಷ ಅಂತೇಳಿ ವಿಜ್ಞಾನ ಕ್ಷೇತ್ರದಲ್ಲಿ ಗುರುತಿಸಲ್ಪಟ್ಟಿತು. ನ್ಯೂಟನ್ ಜನಿಸಿದ್ದು 1642ರಲ್ಲಿ. ಇದೇ ವಿಜ್ಞಾನದ ಮೆಕ್ಯಾನಿಕ್ಸ್ನ ಬೇರೆ ಬೇರೆ ಆಯಾಮಗಳನ್ನು ಅವನು ಚಿಂತಿಸಿ ಕೊನೆಗೆ ಇಂಪಾರ್ಟೆಂಟ್ 3 ಲಾಸ್, 3 ನಿಯಮಗಳನ್ನು ಕೊಟ್ಟ. ಆ ನಿಯಮಗಳನ್ನು ನಾವು ಒಂದೊಂದಾಗಿ ಕಲಿಬೇಕಾಗ್ತದೆ. ಅದರ ಮೊದಲು ನಾವು ವಿ ಹ್ಯಾವ್ ಟು ಸ್ಟಡಿ ದ ಅನದರ್ ಇಂಪಾರ್ಟೆಂಟ್ ವರ್ಡ್, ಇನರ್ಷಿಯಾ. ಇನರ್ಷಿಯಾ, ವಾಟ್ ಈಸ್ ಮೀನ್ ಬೈ ಇನರ್ಷಿಯಾ? ಜಡತ್ವ ಅಂತ ಹೇಳ್ತಾರೆ. ಜಡತ್ವ, ವಾಟ್ ಈಸ್ ಮೀನ್ ಬೈ ಇನರ್ಷಿಯಾ? ವಿ ನೋ ದಟ್ it is the inherent property of the body, or it is the intrinsic property of the body by virtue of which it cannot change its state of rest or uniform motion along a straight line by itself. Or in other words, inertia, it is the inherent property of the body by virtue of which it cannot accelerate by itself. ಒಂದು ವಸ್ತು ತಾನಾಗಿಯೇ ಸ್ವತಂತ್ರವಾಗಿ ತನ್ನ ಸ್ಥಿತಿಯಲ್ಲಿ ಬದಲಾವಣೆಯನ್ನು ತಂದುಕೊಳ್ಳಲಾರದು. ಇದು ಇನರ್ಷಿಯಾ, ಜಡತ್ವ. We can give plenty of examples for those inertia, those word inertia. Initially, let us assume that a passenger is sitting in a bus. Bus suddenly starts moving. He experiencing the backward jerk. Why? Because his lower portion of the body, which is in contact with the bus, starts moving, but the upper portion of the body is still at rest. Therefore, he feels that a backward jerk is experienced by that passenger. Similarly, we can give other examples also. A passenger sitting in a fast moving bus is experiencing a forward jerk. He has a tendency to fall forward because, once again, the reason is same. When he is sitting in a bus, his lower portion of the body comes to rest immediately due to the application of the brakes, but the upper portion of the body is still having inertia. Then, a man who is jumping from a moving bus, having a tendency to move forward 3 to 4 steps to avoid falling down. Otherwise, when it's coming down from the bus, moving bus, we know that, definitely his legs comes to rest immediately, but the upper portion of the body is still having velocity. To avoid that, he has a tendency to fall forward. That is about the inertia. And let us give some other examples. So we know that. ಕೇರಮ್ ಆಡುವಾಗ ಎಲ್ಲ ಕಾಯಿನ್ಗಳನ್ನು ಒಂದರ ಮೇಲೆ ಸೆಟ್ ಮಾಡ್ತೀರಾ ಕೇರಮ್ನಲ್ಲಿ. ಸ್ಟ್ರೈಕರ್ನಿಂದ ಆ ಕಾಯಿನ್ಗಳನ್ನು ನೀವು ಸ್ಟ್ರೈಕ್ ಮಾಡುವಾಗ ಒಂದು ಕಾಯಿನ್ ಮಾತ್ರ ಮೂವ್ ಆಗ್ತದೆ, ಕೆಲವೊಮ್ಮೆ ಎಲ್ಲ ಕಾಯಿನ್ಗಳು ಅದು ಹಾಗೇ ನಿಲ್ತವೆ. ಆ ಎಲ್ಲ ಕಾಯಿನ್ಗಳು 1 by 1 ದೇ ರಿಮೈನ್ಸ್ ಲೈಕ್ ದ್ಯಾಟ್ ಓನ್ಲಿ. ಒಂದು ಕಾಯಿನ್ ಮಾತ್ರ ಮೂವ್ ಆಗ್ತದೆ ಕೆಲವೊಮ್ಮೆ. ಕಾರಣ ಏನು? ಅಲ್ಲಿ ಮತ್ತೆ ಅದೇ ಇನರ್ಷಿಯಾ. ನೀವು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ದು ಕೇವಲ ಕೆಳಗಿನ ಕಾಯಿನ್ನ ಮೇಲೆ ಮಾತ್ರ. ಈ ಎಲ್ಲ ಕಾಯಿನ್ಗಳು ಇನ್ನೂ ರೆಸ್ಟಲ್ಲಿತ್ತು, ಜಡತ್ವದಲ್ಲಿತ್ತು, ಅವುಗಳು ಹಾಗೆಯೇ ಉಳಿದು ಬಿಡ್ತವೆ. ಅದೇ ರೀತಿಯಲ್ಲಿ ಇಫ್ ಯು ಆರ್ ಅಪ್ಲೈಯಿಂಗ್ ಎ ಫೋರ್ಸ್ ಆನ್ ಎ branch of a mango tree containing mangoes, then the branch of a mango tree starts vibrating, but the mangoes which are present in that branch still they are at rest. Finally, due to the vibration, they are detached from the branch. This is also because of inertia. ಸೊ ಇನ್ನು ಸಾಮಾನ್ಯವಾಗಿ ನಾವು ಪ್ರತಿಯೊಬ್ಬರು ನೋಡುವಂತಹ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಅಂದರೆ ಫ್ಯಾನ್. ತಿರುಗುತ್ತಿರುವಂತಹ ಫ್ಯಾನ್ ನಾವು ಸ್ವಿಚ್ ಆಫ್ ಮಾಡಿದರೂ ಕೂಡ ಮತ್ತು ಕೂಡ ಒಂದು 10 ಸೆಕೆಂಡು 15 ಸೆಕೆಂಡು ತಿರುಗುತ್ತಾ ಇರ್ತದೆ. ಒನ್ಸ್ ಅಗೈನ್ ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಡ್ಯೂ ಟು ಇನರ್ಷಿಯಾ ಆಫ್ ಎ ಬಾಡಿ. ಹೀಗೆ ಈ ಜಡತ್ವದ ಕಾರಣದಿಂದ ವಸ್ತುವು ತನ್ನ ಸ್ಥಿತಿಯಲ್ಲಿ ಬದಲಾವಣೆಯನ್ನು ತಂದುಕೊಳ್ಳುವುದಿಲ್ಲ. ದಟ್ ಈಸ್ ಇನರ್ಷಿಯಾ. And Newton explained the first law of motion, so according to which everybody continues to remain in its rest. Everybody continues to remain in its rest or uniform motion along a straight line unless it is compelled by an external force to change that state. I will repeat. You had already studied those statements in previous classes. Everybody continues to remain in its state of rest or uniform motion along a straight line unless it is compelled by an external force to change that state. This law is also called as law of inertia. Why? Because each and every object keep on maintaining its position by virtue of a property which is called as inertia. I had already explained. Because of that inertia, each and every object maintain its state unless the external force is acting on that body. And then, so this is Newton's first law, and he had explained this concept by we can able to explain the Newton's first law by applying different formulae. Initially, the another important word, momentum. Before going to learn second law, we should know the meaning of that word, momentum. What is meant by momentum? What is meant by momentum? That we have to study. The momentum of a body, it is the quantity of motion associated with the body. It is the quantity of motion associated with the body, and it can be measured by the product of mass of the body and its velocity. I will repeat. The momentum is the quantity of motion associated with the body, and it can be measured by the product of mass of the body and its velocity. Definitely, this momentum is a vector quantity because velocity is a vector quantity, momentum is also a vector quantity. And the direction of momentum is same as the direction of velocity. Now let us consider the meaning of that word momentum. It looks to be an ordinary word, but that beautiful word is derived by Newton. So according to this concept, momentum, the total quantity of motion which is moving. To give an example, let us imagine a bus which is moving with a speed of 80 km per hour. Let us consider a bus which is moving with a speed of 80 km per hour. ಯಾರೋ ಒಬ್ಬರು ಅಡ್ಡ ಬಂದರು, immediately by applying a brakes it can be stopped or it can be deviated. So in the same case, let us consider a train which is moving with a speed of same 80 km per hour. If the train is also moving with a speed of 80 km per hour, can we stop it immediately? Definitely it is not at all possible. ಒಮ್ಮೆಲೆ ಆ ಟ್ರೈನನ್ನು ನಿಲ್ಲಿಸಲಿಕ್ಕೆ ಆಗಲ್ಲ. ಯಾಕೆ ಆಗಲ್ಲ? Because both are traveling in the same speed. But we can easily stop the bus, but we can't stop the train immediately. Because here, in the case of a train, the quantity of motion associated with the body is more. It means that mass of the train is larger, hence momentum is larger. Here, the mass of the bus is comparatively lesser, therefore momentum is also lesser. And similarly, let us imagine a car and a heavy loaded truck. A car can be stopped by applying a brakes easily, but we can't stop a heavily loaded truck immediately. Once again, the reason is same. The quantity of motion associated with the body is more. ಇನ್ನು ನೆಕ್ಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಕೊಡಬೇಕು ಅಂತ ಆದರೆ ನಾವು ಬೇರೆ ಬೇರೆ ಚಿತ್ರಗಳಲ್ಲಿ ನೋಡ್ತೇವೆ. ಜಿಂಕೆ ಕಾಡಿನಲ್ಲಿ ಚಂಗನೆ ಹಾರ್ತಾ 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 ಭಾಳ ಚಂದವಾಗಿ ಹೋಗ್ತದೆ. ಆದರೆ ಕಾಡಿನಲ್ಲಿರುವಂತಹ ಆನೆ ಓಡಬೇಕು ಅಂತ ಅದಕ್ಕೂ ಆಸೆ ಉಂಟು, ಓಡಲಿಕ್ಕೆ ಆಗಲ್ಲ. ಯಾಕೆ ಓಡಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ ಅಂದರೆ ಬಿಕಾಸ್ we know that the mass is larger, hence the momentum is also larger. And then let us imagine a bullet. Bullet ಗೊತ್ತಿದೆ, ಗನ್ ನಲ್ಲಿ ಬಳಸುವಂತಹ ಒಂದು ಸಣ್ಣ ಬುಲೆಟ್. ಆ ಬುಲೆಟನ್ನು ನಾವು if you are going to throw that with a moderate speed towards a person, he can easily catch it. No damage takes place. But same bullet is fired towards him by using a gun. So definitely it causes a large damage. It can create a hole even in a human body. Why? Even though the bullet is same, their mass is same, but its velocity is different. So therefore, in the case of momentum, we know that if the mass is larger, momentum is larger. If the velocity is larger, then also the momentum is larger. Such a beautiful word. So that is the momentum. So that momentum is responsible, and so that momentum can be explained in this manner. So now, in the case of Newton's second law, now I will going to define Newton's second law. He gave a beautiful relation between the force and the momentum. I had already told that force is an external agent like pull or push which acts on a body to change the state of the body. The momentum, it is the product of mass of the body and the velocity. Now let us consider Newton's second law. Statement is like that. The rate of change of momentum is directly proportional to the impressed force, and the change takes place in the direction of force. I will repeat. The rate of change of momentum is directly proportional to the impressed force, and the change takes place in the direction of force. It means that, so P, symbolically we are going to represent the momentum by using a letter P. dP, that is the change in momentum, that is the small change in momentum, by dt. So that is the rate of change of momentum, the variation of momentum with respect to time. The rate of change of momentum is directly proportional to the impressed force or the applied force. And now F is directly proportional to dP by dt, or F is equal to K into dP by dt, where K is a proportionality constant, and F is equal to K into d by dt of mass into velocity. So we know that is the momentum, the product of mass and velocity. F is equal to K into d by dt of mv, that is the mass into velocity. Mass of the object remains constant with respect to time. So therefore, K into m dv by dt. F is equal to K into m into dv by dt, or F is equal to K into m into dv by dt. Rate of change of velocity, you had already studied, it is acceleration, therefore it is A, acceleration. And here K is a constant, proportionality constant, m is the mass of the body, and F is the acceleration produced in a body. So if K is equal to 1 in SI units, if you are going to use SI units to explain all those quantities, K is equal to 1 in SI unit, therefore F is equal to m into A. So that is the mathematical form of, that is the mathematical form of Newton's second law. It is a very famous equation. F is equal to m into A. F is the force acting on a body, m is the mass of the body, and A is the acceleration produced in a body. Now we can able to explain the SI unit of force. F is equal to 1, m is equal to 1 kg, A is equal to 1 meter per second square, or F, SI unit of force is Newton. So therefore, by using these concepts, I can able to explain the definition of Newton. One Newton is that force which acts on a body of mass 1 kg produces an acceleration of 1 meter per second square. I will repeat. 1 Newton is that force which acts on a body of mass 1 kg, produces an acceleration of 1 meter per second square. That is the SI unit of force. So, this is the method by which we can remember those definitions very easily. All are equivalent to 1, then F is also becomes equal to 1 Newton. F is equal to ma. That is the mathematical equation for second law, Newton's second law, and we know that if the force is larger on a body, then the acceleration is also larger. So now, let us study another important definition. So that is the impulsive forces. What is meant by impulsive forces? A large amount of force acting on a body for a very short interval of time. A large amount of force acting on a body for a short interval of time, that is called as impulsive force. For example, kicking a ball. If you are kicking a football heavily by applying a large force, that is the example for impulsive force. Knocking a door, ಬಾಗಿಲು ಬಡಿಯುವಂತಹದ್ದು, ಜೋರಾಗಿ ಬೇರೆಯವರ ಮನೆಗೆ ಹೋದರೆ ಬಾಗಿಲು ಬಡಿತೀರಾ? Knocking a door or hammering, you know that. So they are all the examples for impulsive forces. Next, impulse. So what is meant by impulse? So impulse can be defined as it is the product of the average force acting on a body and the time during which the force acts on a body. I will repeat. Impulse of a force, or it is also simply called as impulse. It can be defined as it is the product of average force acting on a body and the time during which the force acted on a body. So this is called as impulse. We are going to use this impulse in different cases. I will go for Newton's third law, the most familiar law to all students. PUC, science ಬಿಟ್ಟು ಹೋದ ನಂತರವೂ ಎಲ್ಲರಿಗೂ ಗೊತ್ತಿರುವಂಥ ಒಂದೇ ಒಂದು ಫಾರ್ಮುಲಾ ಅಂತ ಇದ್ದರೆ, ಒಂದೇ ಒಂದು ಲಾ ಅಂತ ಇದ್ದರೆ ಅದು ನ್ಯೂಟನ್ಸ್ ಥರ್ಡ್ ಲಾ. ಗೊತ್ತಿದೆ? ಟು ಎವರಿ ಆ್ಯಕ್ಷನ್ there is a equal and opposite reaction. To every action there is a equal and opposite reaction. Examples. While walking, ನಾವು ನಡ್ಕೊಂಡು ಹೋಗುವಾಗ ಒಂದು ಕಾಲನ್ನು ಪ್ರೆಸ್ ಮಾಡಿ we are moving forward. ಅಥವಾ a swimmer who is swimming in water, so we know that he is pushing water backward, that is considered to be action, and water pushes him forward, that is called as reaction. Here man who is pushing water backward, that is the action, and water pushes him forward, that is the reaction. Here reaction and action, they are equal and opposite, but they never cancel each other. Please remember that it is the action reaction pair in this case never cancel each other because they are acting on different bodies. Here action is done by a person who is pushing the water backward, but water is pushing him forward, so that is the reaction, therefore they never cancel each other. Similarly, a bat and a ball. Ball is approaching towards the bat and the ball is hitting a bat and it is moving back, so there is the action and reaction. Similarly, We can give some other examples for this Newton's third law. So we know that when a bird is flying, so it is pushing air downwards and it is moving upward. Similarly, a man who is jumping from a boat, when he is moving forward, boat is pushed backward. Boat is pushed backward. So there are all the different examples for Newton's third law. I will going to derive a very important relation, impulse. I had already told that impulse is nothing but it is the average product of average force and the time during which the force acting on your body, F into T or M into A into T or M into A, acceleration. We had already studied in the previous class. So that is the V minus U by T into T. V is equal to U plus AT. U initial velocity, V is the final velocity, A is the acceleration, T is the time. Sometimes instead of U, we are going to use V naught also, no problem. And now M into V minus U by T into T, T cancels. So mv minus mu, that is also equal to I. So therefore mv, the impulse is equal to mv. Mass, m is the mass of the body, v is the final velocity, and therefore m into v is nothing but final momentum. It is the final momentum minus m into u. U is the initial velocity, mass into initial momentum, so that is final momentum minus initial momentum. So therefore, I is nothing but change in momentum, change in momentum. So I is equal to change in momentum. I is equal to change in momentum. It means that it is the difference between the final momentum and the initial momentum. So where v is the final velocity, u is the initial velocity. This is the relation between the impulse and the momentum. Impulse can also be defined as it is nothing but it is equal to the change in momentum produced. Change in momentum produced. So therefore, there is the impulse that is equal to force into time. Here I is equal to change in momentum produced. And then later, now we have to go for the other examples of Newton's third law. And now when rocket is moving upward, so we know that the exhaust gases are coming out. When the exhaust gases are coming down from a nozzle, the rocket is moving upward, that is called as rocket propulsion. There, although it is also an example for Newton's third law. Now, the law of conservation of momentum. The law of conservation of momentum. According to law of conservation of momentum, the total momentum of an isolated system of interacting particles is conserved. I will repeat. The total momentum of an isolated system of interacting particles is conserved. What is the meaning of that? Isolated system. It is a separate system, it is an independent system, or in other words, a system without any external force is called as isolated system. The total momentum remains constant in the case of an isolated system containing the interacting particles. It means that the particles are, even though they are moving, but the total momentum of the system remains constant. So, proof of this law of conservation of momentum. Let us consider two objects. Let us consider two objects A having initial momentum Pa. Let us consider a object B having initial momentum Pb. Both are moving in the same direction. So, this is before collision. Before collision. Let us imagine that if the two bodies A and B collide or interact after collision, so let us consider A, the final momentum of A is Pa dash and the final momentum of the particle B, so it is Pb dash. I will repeat. Here we are the two different objects which are moving in the same direction. Pa and Pb are the moment of two different objects A and B respectively before collision. If they interact or if they collide, definitely their moment changes to Pa dash and Pb dash respectively. Now we have to derive the law of conservation of momentum for these two particles. You had already studied that impulse is equal to change in momentum. Change in momentum. Impulse is equal to change in momentum. So, impulse is equal to force into time, that is the average force acting on your body, and the t, that is the small time interval here, I will consider that is a dt, that is the small time interval during which the interaction takes place or the collision takes place. Force into time, which is equal to change in momentum. So, that is the final momentum minus initial momentum. So, impulse is equal to change in momentum, f into dt, that is the small change in time interval, so during which the collision takes place, is equal to final momentum minus initial momentum. The impulse of body A or the impulse of particle A due to B, that is given by FAB into dt, which is equal to, so the impulse of particle A due to B during a time interval dt is given by FAB into dt is equal to Pa dash minus Pa. That is the final momentum of A minus initial momentum of A, or it can be written as FAB is equal to Pa dash minus Pa divided by dt. Similarly, impulse of B due to A is given by FBA into dt. The impulse of B due to A, due to the interaction with A, into dt, which is equal to final momentum of B minus initial momentum of B. Pb dash is the final momentum after collision. So, we know that this is the case, this is the after collision. And FBA into dt is equal to PB dash minus PB, or it implies that FBA is equal to PB dash minus PB divided by dt. So now we know that according to Newton's third law, the collision of A on B is action, the collision of B with A is a reaction according to Newton's third law. For it to every action there is an equal and opposite reaction. Hence we can write FAB is equal to minus FBA. FAB is equal to minus FBA because this is the action of A on B, there is the reaction of B on A. So FAB is equal to PA dash minus PA by dt is equal to minus PB dash minus PB by dt. So now in this equation this dt cancels, PA dash minus PA is equal to minus PB dash minus plus into minus, that is a minus, minus into minus plus, plus PB. So now in the next step, PA dash minus PB dash is brought towards this side, plus PB dash is equal to PA taken on the other side plus PB. Or now PA plus PB is equal to PA dash plus PB dash. So PA plus PB. PA is the initial momentum of A, PB is the initial momentum of B, PA dash is the final momentum of A, PB dash is the final momentum of B. So therefore, it can be written as PA plus PB is nothing but the total momentum before collision. So total momentum before collision is equal to total momentum before collision is equal to total momentum after collision. Total momentum before collision is equal to total momentum after collision. So that is PA plus PB, which is equal to PA dash plus PB dash. So therefore, hence we can prove the law of conservation of momentum. So initial momentum is equal to final momentum. And now here, if we go back one step, let us consider that m1 is the mass of the first object and the initial velocity is m1 and u, it is the initial velocity u1, and for B mass is m2 and initial velocity is u2. So we know that PA is equal to m1 u1, PB is equal to m2 u2. After collision mass remains same, so we know that PA dash is equal to m1 v1, where m1 is the mass of the A and v1 is the final velocity after collision. Similarly, so here it is PB dash is equal to PB dash m2 v2. Here m2 v2, it can be written as total momentum before collision, PA PA is nothing but M1 U1 PA initial. PA is equal to M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So that is the very important formula to solve many problems. Usually you may definitely come across such problems even in CET or JE like exams. So M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2, where M1 and M2 are the initial mass of A and B respectively. U1 and U2 are the initial velocities. V1, V2 is the final velocities of the object after collision. So therefore, total momentum before collision is equal to total momentum after collision. So that is the law of conservation of momentum. We can give plenty of examples even for that. So let us consider a rocket. I had already mentioned when a rocket is moving forward, so only when the exhaust gases are coming downward. When those exhaust gases are burnt and they are coming down, the forward momentum pushes the rocket upward. Similarly, a boat, when you are getting down from a boat, we know that boat is moving backward and you are moving forward. Similarly, a bat and a ball problem. When a ball approaches the bat, so we know that the momentum gained by that ball due to the interaction with the bat, and it will return at the same path. So that is the law of conservation of momentum. Similarly, we can give the other examples, even gun and a bullet. So gun and a bullet, here if you go through that one, gun and a bullet, so we know that M is the mass of the bullet and U is the initial velocity, initial velocity of the bullet, that is equal to 0, and M is the mass of the gun and its velocity V is equal to 0. And initially gun and a bullet both are at rest, but after firing, so we know that during firing the bullet is moving forward and the gun is moving backward. That is called as recoil velocity. Recoil velocity. So according to that, so initial M1 U1 plus M2 U2 is equal to 0, which is equal to, because why it is 0? Because both are at rest, bullet and a gun both are at rest initially, and after interaction, so we know that, so mv plus m into v, where m is the mass of the bullet, v is the velocity of the bullet, capital M, that is the mass of the gun, v is the velocity of the gun. It is called as recoil velocity because the gun is moving backward. So that is called as recoil velocity. So from that expression we can write v is equal to minus mv by m. So that is the expression for recoil velocity by using the law of conservation of momentum. So here there are so many other uses of law of conservation of momentum also. So now once again I will repeat the statement of law of conservation of momentum. In a total momentum of an isolated system, the total momentum of an isolated system of interacting particles is conserved. Total momentum remains constant. For example, another example, while playing a carom, if you are by using a striker, if you are applying a force or you are imparting a momentum to a single coin, it will collide the other coins, and so definitely, so we know that different coins starts moving it means that the momentum is shifted from one body to the other coins, but the total momentum remains constant. Similarly, while playing billiards or snookers, so you know that total momentum of the system remains constant, and the same principle is used during explosion of a bomb. When the explosion takes place, initially bomb is at rest. During explosion, we know that the different parts of a bomb is scattering in different direction. So they are scattering in different directions, horizontal directions, but the total momentum is conserved. So they are the examples for the law of conservation of momentum. Now let us consider the equilibrium of a body under the action of forces. Equilibrium of a body under the action of forces. What does it mean by equilibrium of a body under the action of forces mean? So let us consider if the two forces acting on a body. If the two forces, let us consider an object like that. If the two forces are acting in F1 and so there is the F2. Here F1 is equal to 10 Newton, F2 is also equal to 10 Newton. Definitely, two forces are acting on a body, even then that object doesn't move. Why? Because the net force acting on a net force acting on a body is equal to 0. F is equal to F1 plus F2 should be equal to 0. It means that F1 is equal to minus F2. So we know that. So they are equal but opposite in direction. So therefore, we can say that this object is under the action of forces, still it is in equilibrium. So, a body is said to be in equilibrium. It means that there is a net force. The net force acting on a body is equal to 0. So, this is the example in the case of two forces acting on a body, each of 10 Newton, but they are applied on a body or they are acting on a body at two different directions, opposite directions. Therefore, net force acting on a body should be equal to 0. We can say that that body is under equilibrium. Similarly, let us consider the three concurrent forces. Three forces, they are the concurrent forces. What is meant by a concurrent force? If the three forces acting at a single point, all the three forces acting at a single point, they are called as concurrent forces. If the three concurrent forces, let us consider like that. So there is F1, F2, they are the two forces, and this is a third force, F3. Here, if you complete the parallelogram, we know that. Now, according to that figure, F1, F2, F3 are the three forces acting on a body. A body is said to be under equilibrium under the action of three concurrent forces. It means that the resultant of these two forces is equal and opposite to the third force. So it means that, this is F3, but equal and opposite. Here, this is the F3 force. The resultant of F1 and F2 is equal and opposite to the third force. When such three forces acting on your body keeps the body under equilibrium. So then we can say that the body is, even though the body experiencing three forces, but that is under equilibrium, or it remains stationary. It doesn't move in any direction. So therefore, F1, here F2 and F3, all are the three concurrent forces acting on a body, keeps the body in equilibrium. It means that resultant of any two forces is equal and opposite to the third force. So let us consider a larger number of forces acting on a body. Then what happened? Once again the condition is same. The net force acting on a body should be equal to 0. It means that here we can say that F1 plus F2 plus F3 should be equal to 0 in this case, or F1 plus F2 is equal to minus F3. It means that the resultant of these two forces is equal and opposite to the third force. Then the body is said to be under equilibrium. If let us imagine that the larger number of forces acting on a body, now the body is in equilibrium, it means that F1 plus F2 plus F3 plus F4 etc. should be equal to 0. The vector sum of all the forces should be equal to 0. It means that the net force acting on a body should be equal to 0. The body is said to be under equilibrium. So that is about the equilibrium. Now let us study the common forces in nature. Common forces in nature. Here you are not going to study all those things in detail. For example, yes, common forces one by one. So initially the spring force, it is also one of the common force. We had already studied 4 fundamental forces in first chapter. Along with that, we come across many forces. So some are contact forces and some are some other forces. So initially the spring force, the second one is gravitational force. The third one is viscous force. So fourth one is the tension in the string. Tension in the string. Fifth one is the frictional force. So there are the few examples for common forces: the spring force, gravitational force, viscous force, tension in the string, and the frictional force. I will briefly explain one by one. Now, spring force. What is meant by a spring force? So we know that spring, if you apply a force on a spring, so that is here the spring. If you apply a force on a spring, so see here, if you apply a force on a spring, if you pull the spring, we know that the elongation takes place. Let it be x. If you pull the spring, the elongation takes place. So due to the application of force, and the length increases, and this much portion is displaced, and I will consider that is the displacement due to the application of force. Here F is directly proportional to x. Force is directly proportional to displacement. What is the meaning of that? If you apply larger amount of force on a spring, if you apply a larger amount of force on a spring, the extension is also larger. But in general, this force means that is the restoring force. It is called as restoring force. Why it is called as restoring force means, according to Newton's law, we know that for every action there is an equal and opposite reaction. If you apply a force on a spring, definitely some forces are internally developed inside the spring. Those forces are developed internally inside the spring. They are called as restoring forces, and this restoring force is directly proportional to displacement, and this F is directly proportional to displacement or some proportionality constant. F is equal to K into X. F is equal to K into X, where K is a proportionality constant. Here usually we are writing it as a negative sign. F is equal to minus K into X, where K is a proportionality constant known as K is a spring constant. It is called a spring constant, or it is also called as a force constant. Force constant K, and the negative sign indicates that the displacement and the force, they are in opposite direction. It means that if you pull the spring, the elongation takes place downwards, the restoring force is opposite to that. So similarly, similar changes are observed during compression also. So therefore, the direction of displacement and the restoring force is always opposite. Therefore, the negative sign signifies that they are in opposite direction. So now let us consider another force, gravitational force. So we know that this gravitational force, so it is the Newton law of gravitation. There is the universal law of gravitation. According to that, we know that m1 is the mass of one body A, m2 is the mass of the another body B. They are separated by a small distance r. Then, according to Newton's law of gravitation, we know that each and every object in the universe attract the other objects with a force which is directly proportional to product of their masses and inversely proportional to square of the distance between them. That is the Newton's law of gravitation. The force of attraction between the two objects, this force of attraction is always directly proportional to product of their masses and inversely proportional to square of the distance between them. F is equal to by G m1 m2 by r square, and that is the mathematical expression for gravitational force, where G is a constant. So that is called as gravitational constant. It is called as a universal gravitational constant, and where m1 and m2 are the two masses of the bodies, r is the distance between these two objects. So that is the law of gravitation. So Newton's law of gravitation, or this is the gravitational force. And the third one is the viscous force. This viscous force is nothing but it is the force acting between the different layers of the liquid. The liquid is assumed to be made up of different layers. The force acting between them, which tends to oppose the relative motion between the layers, and it is called as viscous force. We are going to study those forces in detail in the next classes. And the tension in the string ಅಂದರೆ ತಂತಿ ಅಂತೇಳಿ ಅರ್ಥ. ತಂತಿ, ವೀಣೆಯ ತಂತಿ ಇರ್ಬೋದು, ಬಟ್ಟೆ ಒಣಗಿಸ್ಲಿಕ್ಕೆ ಹಾಕುವಂತಹ ತಂತಿ ಇರ್ಬೋದು. ಬೇರೆ ಬೇರೆ ಕಡೆಯಲ್ಲಿ ನಾವು we are going to use a string. When it is tied at both ends, we know that. When it is tied at both ends, the tension is created on that string, that is called as tension in the string, or it is also a kind of force. Finally, the frictional force. About the frictional force, we are going to study in detail in the next class. Thank you.